Hey guys, my name is xOctoManx and this is part 4 of my Diablo style RPGs tutorial series in Unity 5.6. This again is a Patreon supported tutorial series, so if you like to support me and my channel as well, feel free to go to patreon.com/xOctoManx and donate as well. Okay, in this part we are going to create a script which is controlling the camera, so we're gonna get a kind of isometric view and it's automatically smoothly following our player character in this particular case. So what we're gonna do is we create in our scripts and systems folder, maybe if you don't like to do that in systems you can also go in and place that directly in scripts, but actually it's anyhow a closed system in its own, so we create there a new C# script for this one, and I call this one camera follow. You can also rename it to whatever you like and please, of course, and we open this one up in MonoDevelop. So once this one is going to be opened, we have the possibility to actually create everything again as we please and like. The first one is we need some variables so the camera is able to target something specific. So this is the first one we are going to create, and it's a public one since we want to implement anything we want to target, so we can later on, if we like to, create some conversation target specific stuff. So when we want to play around with the camera, so for example we are talking to an NPC, we can actually drive the camera from the NPC when he's talking and back to our character when he's talking as well, so we can change the target whenever we please and like. Even at let's say we encounter a specific boss or enemy or whatever, so we can go in, take the camera, zoom in maybe, or actually place it directly over the boss, for example. Do everything we want to do, and later on go back with the camera to our character so we can actually start the fight. And that's what we gonna do right now. So we need something of type transform. This is actually going to be our target the camera is looking at. So there are a lot of possibilities we can create this system in here. For this particular camera stuff, I want to implement some headers in here so we later on again see what all this stuff is about. And this one in particular, actually you don't need that, but it's looking cool later on and a bit more organized in the inspector so you can see what's going on in here. So let me zoom in a bit so you can see stuff better. So we have the header target in here, so everything about the target basically would land directly under that header. I believe we already have created this header in another video. So what we can do is we can take this camera follow script right now and drag this one directly onto our main camera we already have in here. So when we're dragging this one in, you can see that bold line or bold text. And we have the public field for our target. So the target again later on is going to be the player. What we want to do now is we want to make sure that we are checking if there is any target set, and we're gonna do that directly in update. But what we also can do is we can also use late update, I believe. So we change the normal update function to late update. So in the late update, that means when basically the frame is already over, we're gonna do all the update stuff with the camera in this particular case. So what we check is if we have no target set in the inspector, or we haven't done anything at all, we want to make sure that we return. I'm gonna comment this out in a moment. Also we want to print maybe a message. You can also use a debug line in this case, and we just send this one to the console, so we're gonna get an info no target set for the camera. You can write this one as I do, it doesn't really matter. You just want to make sure that this is implemented. When we are returning, again we are leaving the complete F statement and also the complete frame actually. So at this particular point we break completely out of it and we're gonna return, or actually we start all over and see if there is a target set or not. If not, once again it's going to be every frame returning when we are not setting any target. So, but when we have a target, of course, we want to follow it. We need to implement several things first. So the first one is I'm gonna create another header in here so we can again see stuff better in the inspector later on. It's better or a bit more organized. I call this one just distances. So since we have several different distances, we can arrange them inside that distances part actually. So the first one is just a basic distance, and I want to set a specific range to it, but we go over and do the range stuff in a moment. So the first one is, it's going to be a public, type is float, and I call this one just distance. So the distance, we can actually set this one to maybe 5f at the beginning. It doesn't really matter, we don't need to, don't need to set this one, later on it will be set automatically, I guess. So this distance is basically representing every distance in the x, y, and z axis, or z axis. We could even go in and split everything up, but basically since we have an isometric view, we always have the same distance from the x, y, and z distance depending on wherever the camera is. So we don't have any, well, orthographic view in this case, or, well, not orthographic view, but we don't have any orbit view actually, where we need to decrement or increment the height separately from the distance directly to the player, because it is isometric. So we always want to make sure that the distance in all three axes is going to keep and stay at the same. Okay, so next one is I want to implement an offset. This is of type vector3. We could also use a float, but what we need to do is I want to make sure that we have the possibility to set every distance as an extra offset. In this case, we just need to go in and set an extra offset for the y-axis. But later on, you might want to go in and fiddle around with the offsets in any other particular case, depending on maybe how big a monster or a boss is or whatever. So we might want to go in and give that a specific offset at that particular point. So we don't set the offset in here. We're gonna do that later on in the inspector, and I'm gonna show you what this is about. And another one is we have some speed variables. So we create a new header for this one in here. So again, we're gonna have or keep that as organized as possible and call this just speeds. And what we implement in here is at first a public float, and this is going to be our, well, actually it's not a smooth speed, but it's kind of camera speed in this case. We can set this one to maybe 5f at the very beginning, so it's rather a small number, and we're gonna need another float in here, and this is going to be our scroll sensitivity. I'm gonna set this one to maybe 2 or 1 for now. We're gonna rearrange all that stuff. Okay, so once again, the smooth speed is actually the speed what we're gonna take when we are going to the character or away the character, or actually not the character but the target. The scroll sensitivity is basically when we are using our mouse wheel into a positive or negative direction. When we are wheeling around with that, we want to make sure that we can or have the possibility to make it faster or slower. I'm gonna explain this in a moment when we're going to this scroll stuff. To get this stuff run. Don't forget to save in between so we don't lose anything in here if, well, mono developers crashing or whatever. Okay, so now let's get into the mess. So what's happening in here? So let's create a float in here. So this number actually represents the scroll. So what we want to do is when we are scrolling in a specific direction, we want to implement or decrement from the distance we are currently at. So what we take is the input dot get axis, which is this one, and in open close parentheses and in those quotes we're gonna type in mouse with a big M in the beginning and scroll wheel. So scroll with a big S in the beginning and wheel with a big W. Make sure you have no typo in here, otherwise this is not working. So when we are wheeling around with the mouse, we want to make sure that the distance is going to be decremented by number, the number we're gonna have, times this the scroll sensitivity. So this just implements or increments this one by whatever the whatever the speed actually is. Normally or usually get-axis scroll wheel, depending on how fast I guess you are scrolling, it adds up, or it's going to be a positive or negative number, and it is always going to be 0.1. It will never be higher than 1 and never lower than 0. So what we get is we get that number 0.1, and we decrement the distance times the scroll sensitivity, depending on, of course, how big this one is. So let's assume we're gonna zoom in one direction. We're gonna have 0.1, and when our scroll sensitivity is maybe 5, we're gonna update this one at the distance. So we're gonna take 0.1 times 5 is going to be 0.5. And this would be decremented from the distance. Why decremented is depending on if the scroll wheel is going to be in the positive direction, it's going to be zooming in or zooming out. When you feel that is wrong, then you can always go in and add a plus in here instead of a minus. Also, what we want to do is we want to clamp the distance between two values. We can actually set the values directly also in the distances for a max and minimum distance, but we can also do that directly inside of here. You decide what you want, and please, depending on how much influence you want to have from the script directly in the inspector. So what we're gonna do is we set distance to be equal to massf.clamp. And what we can do is we clamp this particular value, which is going to be distance, between two numbers, a minimum and a maximum float. Let's start with the minimum float is going to be maybe 1f, and the maximum maybe 7f. Again, we have the possibility to take those values and pass this also directly in here. So for example, we can create a new public float. At the very top in here we can say minimum distance, maybe min distance. We can also type this one out, doesn't matter. And we can also say public float max distance. So we have direct access to that distances and can actually, we don't need to go back into the code and change this. We can do all that stuff inside the inspector. So for example, we set this one in here already to 1f and to 7f at the maximum distance, the same as we already did in here in the massf.clamp. And instead of 1f, we just type in min distance, and instead of 7f, max distance. So now we clamp this distance value in between the minimum and the maximum distance we just set in here. Once again, we need to make sure that we change all of that stuff depending on what we need in later on in the inspector. Okay, so this is just setting the distance when we are scrolling around. But what we also want to do is we want to have the camera follow our target. So again, this is dependent on if that is set by our player or our enemy, if we have some story to tell or whatever. So at first, to get this stuff running, we're gonna need to create a new vector3, which is actually just holding the target's position, and we call this one just pause. And we're gonna say this is going to be the, again, as I said, target.position. And what we also want to increment it by is the offset I was just talking about. I'm gonna show you later on what the offset is going to do for us. Okay, so now we have catched the this position, but what we want to do is we want to decrement stuff from the position. So pause is minus equal transform.forward, so the forward axis, the forward local axis, from the camera times whatever the distance is. So we decrement that forward axis wherever it's locally looking at times the distance. So if the distance is 1, it will be in all position, or actually in all axes, it will be that particular distance times whatever. Yeah, in this case it's just a 1. In all axes, I guess, or actually in the z-axis, but the local z-axis in this case. So we decrement this camera, or actually this position of the target, by whatever the camera is currently doing. Okay, and at the very last we want to make sure that the camera is lerping smoothly to whatever the position is we're gonna request in here from the current position we are currently at. So what we do is we say transform.position is going to be equal to vector3 dot lerp, and we open close parentheses. The first one is we want to go from a particular position, so we lerp from transform.position comma to position. So this is vector b actually, or the second vector, as you can see always over here in the lerp function itself. And now we need a speed, and in this case we're gonna take smooth speed times time dot delta time. Don't forget to add a semicolon at the very end of the line. And let's save the script and see what we have done so far. So we're gonna wait until Unity has compiled everything, and now you can see we have a pretty goodly organized little camera follow script in here. We have some speed, the scroll sensitivity, and all the other things. We're gonna start with a distance of 5. We have a minimum distance, a maximum distance of 7, and we're gonna clamp them inside of that. We can later on change that distance value, or actually clamp this one as well, so you don't, or you're not able to over or underdo that in here. I'm gonna show you this one in a second as well. Okay, so what we want to do is we would want to drag for now our player into the target slot in here, so the camera knows now, okay, this is going to be our target. So let's see what the camera is going to do in here. As you can see, it's pretty much low in the height, and what we want to do is we want to test if the camera is following. And I'm gonna click around, and you can see pretty good. And when I scroll in, I'm gonna scroll to the feet. When I scroll out, I am over here, but I still look at the feet. That's where the offset is later on coming in place. If I want to implement the height, so I maybe look at onto the chest, I can always do so and just implement one at the offset in the Y offset in here. So when I now scroll in, I'm gonna scroll to the chest, because this character is about 2 in the height. You can always play around with that. If you want to zoom in more to the head, well, feel free to do so. Okay, so we have the scrolling done. What I also want to show you is the rotation. When we actually have, this is not an isometric view actually. I'm gonna change that inside the Y-axis once again to 1. So the offset is still going to be set to the chest, or whatever it's called. What I want to do is when I now, for example, rotate this one on the x-axis to 45, so we are looking down in a 45-degree angle, and we're gonna do the same for the y-axis, maybe in a 45-degree angle. You can see the camera is actually looking, pretty much isometric, or almost isometric. When I now press play, we should see that the camera is directly looking onto the backside, or actually the center point of the character. We are able to scroll in and scroll out, but you can also see the ranges might look a bit different. But we can look around here and we can walk around, and the camera is going to look and follow pretty smoothly. What I want to make sure is that the minimum distance is not lower than 2, since I don't want to go too close to my character, because actually it doesn't make sense. So this is now the distance of 2. This is going to be the distance of 7. If you don't like 7, well, maybe decrease or increase it, of course, to whatever you please and like. What you also maybe have seen is the scroll speed could be maybe a bit faster. So I'm gonna increase the scroll sensitivity by 5 or to 5. So instead of 0.1 increase in the scroll sensitivity, I just gonna do 0.5 steps. You can also see the steps and the current distance over here. So the distance is automatically later on calculated. We're gonna start at 5, but as you can see, it's always going to be incremented by 0.5 when I once hit that, or actually once get into that scrolling in here. Again, you can always go in and maybe do it to 10. So 10 by 0.1 is going to be 1. So every time we would scroll in here, we would go one distance, one distance in every axis while scrolling around. So it's pretty goodly moving in here. Again, the speed is not just the scroll, but also the lerping speed. If you would increase the lerp as well, which is the smooth speed in this case, it might also go in a bit smoother or not. Let's assume we have a scroll speed of 1. You would see this is, well, pretty slowly moving to that position. As you can see, rather smooth. But I guess 5 is not too bad at all. And what we now have is, a camera follow script, which has the possibility to go to a specific position or actually follow whatever we want to follow. Let's assume we drag in an enemy while the game is running into that target slot. Please check what's happening in here. I just drag in our enemy. What you can see, it automatically goes smoothly to the enemy, and we can do whatever we like and please when we are actually telling or calling or whatever, telling any story. And then when the conversion or conversation is ended, we're gonna go back to our character, for example, and that's pretty much cool. So maybe you want to decrement or decrease the smooth speed to 2 or something. Well, again, you need to decide what you please and like. And later on, of course, we can call that functions when we are in a conversation with an enemy or a boss or whatever. So we can manipulate the smooth speed. Gonna set this one to 1 now. Let's see how this is looking. So you're gonna have the conversation in between those two characters, and that's smoothly running from one point, or actually going from one point to another. Okay, so actually that's the starting distance. We can also go in and clamp this value at the very beginning, because you might want or might have to encounter any problems with that. We could also, we keep it as it is at the moment. But what I want to make sure is that we actually clamp the input with a range slider. So we add a range slider in here, and we want to range this one basically to the minimum and the maximum distance. I'm not 100% sure if this is possible to do so, but we're gonna try this out. No, at this point, minimum and maximum distance are not, well, actually not here. So we might want to clamp this one between maybe, I don't know, maybe something between 2 and 10. It doesn't really matter, but I show you what's happening with that range slider when it is done compiling in Unity. So the distance will not be a plain number anymore, but it will be a slider. So we can change that slider to whatever the value is we like. We can also type in any number in here, and this is going to be wherever we want this be to start when we are starting the game. Now it should start at a distance of 2. So because that's the minimum value, also we can actually access that slider right now and slide in and out to whatever we like and please. But also what you can see is we are not able to overdo it, because 7 is a clamped value actually in here, or depending on the maximum distance. Maybe we are able to do this like that. I'm gonna check this one out. No, we are not able to do that. I didn't know, so I just needed to test this. You don't need to do that. So I undo everything in here. So yeah, that's everything we want to know and we want to play around with. Again, since this is already clamped in here, I want to make sure that the 7, or actually this second number in here, is not higher than the maximum distance we're gonna set in here. So maybe when we set this one to 7 in our distance settings anyways, then we might want to go in and take that as a main number where we are actually clamping this one, just to make sure that we set this one to a particular distance to our needs. We could also go in and put the rotation values so we can actually keep this camera as it is, but I guess you would figure this out on your own how this is going to work. If not, feel free to ask me in the comments below or send me a private message or whatever. So that's everything I wanted to cover in this little tutorial about the camera, which is smoothly following right now. We have the possibility to enter any target we want. We can set the distance with our mouse wheel directly when we are playing the game. And we also should have everything cool when it is in full screen mode. So everything else, like, yeah, as you have seen already in here, our cursor is still looking cool. We can move around in here, we can check for other things in here, and we can do everything what we have already done beforehand. We can still attack, well, actually just play the attack animation. And that's everything for this little tutorial. Thanks for watching the tutorial. I hope you enjoyed it. Don't forget to subscribe to my channel if you haven't already. Thumb this video up if you like it, and feel free to become my patron or donate by using PayPal to support me and my channel in the future. All links will be below in the description. See you in the next tutorial. Bye bye.